In this video, we're going to complete the KutaSoftware Infinite Calculus free worksheet, Derivative at a Value. So for each problem on this worksheet, we're going to find the derivative of the function at the given value. So the steps to find the derivative at a value: first, we calculate the derivative, and then we plug in our x value and solve. So for number 1, we have y equal to x squared plus 4x, and we're finding the derivative of that function at x equals negative 5. So finding the derivative, dy dx, using the rule of sums, we're going to take the derivative of x squared and add that to the derivative of 4x. The derivative of x squared, using the power rule, will be 2 times x to the 2 minus 1, which is 1. So we'll have 2x plus, and now the derivative of 4x to the first, that 1 will get multiplied by the coefficient 4, so that's 4, and then times x to the 1 minus 1, which is x to the 0, and that is equal to 1. So now that we have the derivative of y with respect to x, we're going to plug in negative 5 for x. So we're going to get 2 times negative 5 plus 4, which 2 times negative 5 is negative 10, and adding 4 to that, negative 10 plus 4 equals a negative 6. So the derivative of y with respect to x at the given value of x equals negative 5, that's equivalent to negative 6. And this is the notation we're going to use to write the derivative at a given value. So let's continue on to number 2. Number 2, we're going to find the derivative of y with respect to x. That's going to be the derivative of negative x cubed, so that's negative 3x to the 3 minus 1, or negative 3x squared, and then we'll be adding that to the derivative of 4x squared, which is 2 times 4 times x to the 2 minus 1. 2 times 4 is 8, and x to the 2 minus 1 is x to the 1, or simply x, and the derivative of a constant is 0, so subtracting 0, we're not changing that value. So now that we have our derivative of our function y with respect to x, we're going to plug in that value of 4 for x. So we'll have negative 3 times 4 squared plus 8 times 4. So that's negative 3 times 4 squared is times 16 plus 8 times 4 is 32. So negative 3 times 16 is a negative 48, and when we add that to 32, we get negative 16. So the derivative of y with respect to x at x equals 4 equals negative 16. Now on to number 3. In number 3, we're going to be calculating the derivative of 20 over x squared plus 5. So remember, we're going to use the quotient rule. That's low d high, so low is x squared plus 5 times the derivative of our numerator, so the derivative of 20, minus high, that's our numerator, times the derivative of our denominator, all over our denominator squared. X squared plus 5 squared. So calculating this out, x squared plus 5 will be multiplied to the derivative of 20, and 20 is a constant, so that's getting multiplied to 0. And then we're subtracting 20 times the derivative of x squared plus 5 is 2x, because the derivative of x squared is 2x and the derivative of 5 is 0, and 2x plus 0 is 2x. And that's all over our denominator of x squared plus 5 squared. Now simplifying, you can see that x squared plus 5 times 0 is 0. So now I'll just take that value of 3 and plug it in for x. So I'll have negative 20 times 2 times 3 all over 3 squared plus 5 squared. Negative 20 times 2 times 3 is negative 20 times 6, which is negative 120, and that's all over 3 squared, which is 9, plus 5, which is 14, and 14 squared equals 196. 120 and 196 are both divisible by 4. So when I simplify, the derivative of y with respect to x at x equals 3 equals, dividing both by 4, that's going to be negative 30 over 49. Negative 30/49 is my solution for the derivative of my function at x equals 3. Now on to number 4. Again, we're going to use that quotient rule, low d high minus high d low, all over low low. So low, x plus 1, times the derivative of high, the derivative of the numerator, is 0, minus high, 2, times the derivative of our denominator, which is going to be 1, because the derivative of x is 1, and the derivative of 1 is 0, and 1 plus 0 is 1. And that's all over our denominator squared, x plus 1 squared, low squared. So simplifying, we can see that x plus 1 and 0 will cancel out, so we'll get negative 2 over x plus 1 squared. Now that we've simplified, we can take our value of 5 and plug that in for x in our derivative equation. So we'll get negative 2 all over 5 plus 1 squared. That's negative 2 over 5 plus 1 squared, which is 6 squared, or 36. Now I can simplify negative 2 over 36 because both are divisible by 2. So the derivative of y with respect to x at x equals 5 equals negative 1/18. 2 divided by 2 is 1, and 36 divided by 2 is 18. So negative 2/36 simplifies to negative 1/18. That's my solution in number 4. In number 5, I'm going to calculate the derivative of y with respect to x, and then I'm plugging in a value of 0 for x. So for this problem, I'm going to use the chain rule. So I'm going to set y equal to u to the 1/2, and u is going to equal negative x plus 4. So you can see that if I take negative x plus 4 and plug that in for u, I'll get y of negative x plus 4 to the 1/2. So utilizing the chain rule, we're going to find the derivative of y with respect to u, which is going to be 1/2 times u to the negative 1/2. That's 1/2 times u to the 1/2 minus 1, which is negative 1/2. But because we know that u is equal to negative x plus 4, we'll plug that in. So we'll get 1/2 times negative x plus 4 to the negative 1/2. And now we'll find the derivative of u with respect to x, which the derivative of negative x plus 4 is a negative 1. So in order to get the derivative of y with respect to x, we need to multiply the derivative of y with respect to u by the derivative of u with respect to x. So the derivative of y with respect to u times the derivative of u with respect to x is going to be this quantity multiplied by a negative 1, which is going to be negative 1 over 2 times negative x plus 4 to the positive 1/2. Writing this term with an exponent of a negative value in the denominator with an exponent of a positive value. And that is all multiplied by 1/2, and then a negative 1. So now that I have my derivative formula, I'll be able to take my value of 0 and plug that in for x. So I'll get negative 1 all over 2 times 0 plus 4, which is times 4 to the 1/2. So we'll have negative 1 over 2 times 4 to the 1/2 is 2 times the square root of 4. So 2 times 2. Therefore, my derivative of y with respect to x at x equals 0 is negative 1 over 2 times 2, which is negative 1 over 4, or negative 1/4. So negative 1/4 is my solution in number 5. In number 6, again, we're going to be applying this chain rule. So we're looking at that outermost function, and then we're looking at that inner function. So we can think of this as negative 3x plus 9 as u, and that's u to the 1/2. So the derivative of y with respect to x, we're finding the derivative of y with respect to u. So that's going to be 1/2 times u to the negative 1/2, 1/2 minus 1. So again, we're taking 1/2, bringing it down in front, and then subtracting 1/2 by a positive 1, which in this case will be 2 over 2. So that's 1/2 of u, which is negative 3x plus 9, to the 1 minus 2, which is negative 1 over 2, so negative 1/2. And remember, that is multiplied by the derivative of u with respect to x. So the derivative of negative 3x plus 9. The derivative of 9 is 0, and the derivative of negative 3x is negative 3. So this will get multiplied by negative 3. Simplifying, I'll get negative 3 over 2 times negative 3x plus 9 to the 1/2. Or I can write that as 2 times the square root of negative 3x plus 9. Because taking the square root of a value is the same as raising that value to the 1/2. So now that I have my derivative, I'm going to plug in my value of negative 5 for x and solve. So this will be negative 3 over 2 times the square root of negative 3 times negative 5 plus 9. That's going to be negative 3 over 2 times the square root of negative 3 times negative 5 is a positive 15, and adding 9 to that will give me 24. Now, I don't want a radical in my denominator, so I'm going to need to simplify. So I'll rewrite negative 3 over 2 times the square root of 24 as negative 3 over 2 times the square root of 4 times 6. And I rewrote 24 as 4 times 6 because I know 4 is a perfect square. So now when simplifying, I'll have negative 3 over 2 times the square root of 6. Because 2 squared is equal to 4, so when I take the square root of 4, I get 2. And my last step that I want to do now is multiply by the square root of 6 over the square root of 6 to get that out of the denominator. So negative 3 times the square root of 6 will be negative 3 square root of 6 all over 2 times 2, which is 4, times the square root of 6 times the square root of 6 will be 4 times 6. And 4 times 6 is 24, but I know that both 3 and 24 are divisible by 3, so I'll get negative 1 times the square root of 6, or negative square root of 6, all over 24 divided by 3, which is 8. So negative square root of 6 over 8 is my solution. So writing this in the proper notation, derivative of y with respect to x at x equals negative 5 equals negative square root of 6 over 8. Now quickly I want to note that if you could get to this point, you're on the right path. The only thing you need practice on is simplification of radicals. So if you could get here on your own, you understand the methods of evaluating a derivative at a given value. And if you messed up somewhere in the simplification process, then you'll have a good idea of what you practice. But if you can at least show that you can get to this point, you'll most likely get partial credit on your answer. So remember to always show your work and always write down all of your steps. Partial credit is better than 0 credit. So negative square root of 6 over 8 was our solution in number 6. Now, on to number 7. In number 7, it's helpful to remember that the derivative of e to the x is e to the x. However, for this, we're going to need to use that chain rule. So we're going to take the derivative of e to the u and then take the derivative of u. So the derivative of y with respect to x, the derivative of e to the u is e to the u. So that's going to be e to the negative x plus 2 if we set u equal to negative x plus 2. And then we're going to multiply by the derivative of u with respect to x, which is a negative 1. So for our derivative of our function in number 7, we have negative e to the negative x plus 2. Now we're going to take our value of 4 and plug that in for x. Plugging in our value of 4 for x will give us negative e to the negative 4 plus 2, which equals negative e to the negative 2, which we will write as negative 1 over e to the positive 2. Because remember, when we have a negative exponent, we can write that term in the denominator with a positive exponent. And there we have it. That's our answer in number 7. The derivative of y with respect to x at x equals 4 equals negative 1 over e squared. And number 8, it's important to remember that the derivative of the ln of a function is 1 over that function. So the derivative of y with respect to x is going to be negative 1 over our function x plus 3. And once we find the derivative of that outside function, we need to find the derivative of our inside function. However, the derivative of x plus 3 is 1, and multiplying by 1 does not change our value. So our derivative in number 8 is negative 1 over x plus 3. And we're going to enter in 5 for x in number 8. So entering in 5 for x will give us negative 1 over 5 plus 3, which equals negative 1/8. So the derivative of y with respect to x at x equals 5 equals negative 1/8. Now on to number 9. In number 9, we can use the constant multiple rule and pull out this 2. So we know the derivative of y with respect to x is going to equal 2 times the derivative of the sine of 2x. So the derivative of the sine of some function times the derivative of that inner function. So applying the chain rule, the derivative of the sine of 2x is the cosine of 2x, and the derivative of 2x is 2. So what I did, I set 2x as u and found the derivative of the sine of u, which is the cosine of u. So then I plugged u back in, so 2 times the cosine of u, 2 times the cosine of 2x, times the derivative of u, which the derivative of 2x is 2. So simplifying, 2 times 2 is 4, so I'll have 4 times the cosine of 2x. Now I can plug in my x value of negative pi over 2. So plugging in negative pi over 2, I'll get 4 times the cosine of 2 times negative pi over 2, which is equal to 4 times the cosine of negative pi. And if you remember on our unit circle, pi occurs here, here's 0, so negative pi is where pi is. And the cosine is that x value at negative pi, which is a negative 1. So we'll have 4 times negative 1, which equals a negative 4. So the derivative of y with respect to x at x equals negative pi over 2 is equivalent to negative 4. And lastly, number 10. We have y equal to negative tangent of 2x. So I'm going to evaluate the derivative of the tangent of u and then multiply that by the derivative of u. And this negative is out in front, and because of the constant multiple rule, that will also be applied within that derivative. So the derivative of y with respect to x is going to be equal to negative the derivative of tangent u is secant squared u. So negative secant squared of u, which we know is 2x, and that will get multiplied by the derivative of 2x, which is 2. So we'll have negative 2 times the secant squared of 2x. Now we can take our value of negative pi and plug that in for x. So we'll have negative 2 times the secant squared of 2 times negative pi, or negative 2 pi. That's going to be negative 2 times the secant squared of negative 2 pi is going to be 1 squared, which is 1. So we'll have negative 2 times a positive 1, which equals negative 2. Therefore, in number 10, our last and final solution on this worksheet, the derivative of y with respect to x at x equals negative pi equals a negative 2. And that's my solution in number 10. Also, if you want to think of secant as 1 over the cosine, would be 1 over the cosine squared of that negative 2 pi, which, when we're at negative 2 pi, we're at this point here, where the cosine is a positive 1, because here would be negative pi, and then keep going around to negative 2 pi. So the cosine of negative 2 pi is 1, cosine squared is 1, and 1 over 1 is 1. Therefore, negative 2 times 1 equals negative 2, which gives us our solution for our derivative in number 10 at x equals negative pi to be equal to negative 2. If you have any questions, please feel free to leave them in the comments below, and I or one of your peers will get back to you as soon as possible. If you were confused on any of the rules we used in numbers 1 through 10, please visit a previous worksheet or a previous tutorial in which I explain sum rule, difference rule, power rule, product rule, quotient rule, and the derivatives of natural logs and trigonometric functions. So this was just a matter of finding that derivative and plugging the value in. But hopefully you found this helpful, and if you did, give me a thumbs up on this video, subscribe to my channel, and share this with your peers. All likes and subscriptions are greatly appreciated.